everybody, and welcome to another wonderful Friday edition of From the Desk of Lady Ada. It's me, I'm Lady Ada, I'm the engineer, and I'm here at my home desk where I do some fun home engineering, I guess. And tonight we're going to have a show where I basically write a graphics driver for this LED matrix that I've been working on. Actually, this is a very old project that I've finally got the energy to revive and finish. It's a really cool LED PWM driver that just basically put together today and got it working. So let's go to either the overhead or computer. Either one's good. Let's do the overhead. Overhead first. Yes, I'll show it off. This is the PCBs for this design. So this just shows you it's multiple LEDs in a grid. I think it's 9 by 16 grid of LEDs. These are 603 LEDs, and they're not Charlie-plex, but they're multiplexed onto 16 lines that go to a chip. And then the way I did it, I'll just take this apart, is the LED matrix here, this LED grid of 144 LEDs, plugs into this board, which has a little chip in the middle, and this chip is an I2C LED PWM driver. And what's really neat about this is it can multiplex control, again, 9 by 16 LEDs of a single color, red, yellow, green, blue, whatever. It does it all over I2C, and it can adjust the brightness of each LED in the matrix as well. So that's unusual. Usually, LED drivers don't have individual LED PWM control, but this one does. So let's plug this back in and reset it. So you can see I've got a gradient going on here, and then the gradient gets brighter and brighter and brighter, and then it eventually resets and then gets dim again and then gets brighter and brighter and brighter and brighter. So what I'm just doing for this demo test is having each LED increment in brightness until it gets to the most, 255, and then it resets and starts at 0. And so this is just my test to get LED control. Isn't it wonderful? I can control the brightness of every LED, and that's fun and everything. But a lot of times, if you have a grid of LEDs, you want to do something like print text or draw circles or squares or lines or do dots as an XY pattern. And rather than writing a library from scratch that does all of that stuff, what I'm going to do is do what I've done with pretty much every graphical type display that we have, which is subclass the Adafruit GFX library. So let's go to the computer and we'll take a look at that stuff. Okay, so let's open up the libraries, and I'll show off Adafruit GFX. This is Adafruit GFX. I'm going to actually do a git pull because it's been a while, and there might have been some other people who've made updates. Nope, it's pretty much up to date. And Adafruit GFX is a C++ library that extends the print subclass, so you can, basically write characters and lines to it. It uses the the floating point and like hexadecimal formatting that is built into the Arduino IDE. And then what's neat is that you have one virtual void function called drawPixel. So the GFX library doesn't actually know how to draw a pixel. It knows that there's going to be, that if you subclass this function as this class, you're going to have X, Y color, and that will draw the pixel. But it in and of itself does not draw pixels. However, what it does know how to do is, if there's a draw pixel command, it can draw lines, it can draw rectangles, it can draw ovals, it can draw cursors, text, bitmaps, round rects, triangles, and you can fill them, and it kind of does all of the logic of doing graphics without having to duplicate that code over and over again for like an OLED display or a TFT display or an LCD display or this LED display. So you can see here, for example, draw a circle. It calls draw a pixel. Draw a circle here, you give it the X, Y, and then the radius and the color. It draws all the pixels and it uses, this funky non-floating point math, which is, you can check Wikipedia for circle drawing algorithms. This is kind of a well-known circle drawing algorithm. It just kind of goes around the circle and draws all the pixels for you. And then it just assumes that your underlying class draws the actual pixel. And that's perfect because what I've done with this LED matrix is I've individually controlled every LED. So all I have to do is basically subclass this, add draw pixel, and I'm done. Because I just use GFX to do all the circles and squares and lines and everything. Because drawing a line on an OLED is going to be the same as drawing a line on a TFT, same as LED. It's just, you have X and Y and the end to X and Y, and then you just draw all the pixels in between. So let's start a new library. And I can't remember the name of this chip. It's so annoying. IS31FL 3731. Okay, golden. Whoa. And because I just do this so much, I'm actually going to see which is a good one to borrow from. PCD. Oh, you know what? NeoMatrix is a good one. So NeoMatrix is also uses Adafruit GFX, and so I'm just going to remind myself of how it does it by checking this out. Okay, so let's go to Adafruit IS. This is just too many libraries. Make a new text file called Adafruit IS31FL3731. And then .h. And start editing it. And I'm just going to crib a little bit from the NeoMatrix just because it's all these things I always have to remember how to do, or all the includes that I have to have. So I'm gonna, don't forget your guards for including. Oh. FL37, I'm gonna get real used to that. At the bottom, and if. Have some includes we need. These days, though, I'm kind of not supporting anything under Arduino 1.0. I think that's fair. And then, of course, I'm going to the class. And then this is a subclass of the GFX library. It's public because I allow the superclass to people who are defining the superclass to call the graphics functions, otherwise it wouldn't be much point. And then there is the constructor, which I know is not going to have anything. It's an I2C device, so it doesn't need anything. And then I have to remember, I have to basically define draw pixel. And I don't have to define anything else. This is actually kind of the minimum. Don't forget, this is the public stuff. Later on, I'm going to have a I2C address, because it has an adjustable I2C address. I think it's good to go. Okay, cool. That's not too bad. Okay, now on to the C++ file. So I'm going to grab the same includes, because I'm going to need those no matter what. And then, of course, I'm going to also include header file that I just made. I'm sure like I mistyped the part number like 8 times. And then I actually have, so I have some code that I wrote that's, you know, the code that I wrote to control the LED is like just this raw. That's correct. Thank you, Tony Nicola. I would have hit a compile error. You are a live parser. So I should have gone to the end. I would have been like, yeah. I don't do this though. I'm like, why? It's like, you know what the end if it's for. Okay.
I like the soft I squared C
The underscore.
I like the soft I squared C
Soft I squared C. Okay. Okay, so this is the function that I wrote. So before I write a library, I just like have a sketch and I just like go in there and I'm just like, whatever you got to do just to get something responding. Like I don't start with a class, I start with a sketch because it's just fast and it's easy and it's just like, okay, what register do I need? Okay, just define them, get stuff. So I'm also going to include wire, so I'm going to add that in. And then I'm going to do some like awesome double action Xemax. And then I'm just going to put in my all these defines I made. Why not? They're not complete. So like I have the like it actually, this chip does quite a bit. It has this animation capability where you have like multiple frames. I do want to add that. And this shows you the chip itself. So the chip uses I2C, has an interrupt pin, has a shutdown pin, has an audio in pin, which is kind of weird. You can use audio in and it will modulate the entire matrix. I can show that later if I have time. RX, which probably sets the current that goes through all the LEDs. Like you want to set like what's your max current. C filter is used for audio stuff, I think. Ground, and then it has 9x9 grid. And here's the thing about this grid. You're probably like, oh, I totally want to hook up my 8x8 LED matrix to this. You can't. You're about to do it, and you can't do that. This grid is not a true multiplex grid. They do some like funky interspersing of the anodes and cathode lines. So for example here, this isn't connected. But like, sorry, this not that one. It's, sorry, these are all connected, but then here, this goes through, but then this is connected. And then, try to see where else it was. Like it's very deceptive. There's, basically it gets cut in half. And so that allows you to actually have 2 matrix grids that use the same. So this actually allows you to control more than 9x9. It's 14x9 LEDs. By having this grid not be a true cross grid. It's not like a true crossbar grid. Anyways, I'm trying to see where else it varies. Like here it varies, and then here it touches, and here it touches, and here it touches. So it touches the 2 lines intersect only on this diagonal, but then if you see every other cross point, it doesn't. Anyways, that was fun to lay out, I'm sure. Yeah, and then this tells you like what the average current of LED, and you can adjust the current by setting RX. That's kind of handy. Basically, it just uses I2C, but you can change the address with the addr pin. Sorry, AD is the address pin. You can change the address up to 4 addresses. So you can theoretically have 4 of these LED grids. Where was I? Oh, right. I was going to, I got all these registers. So there's a bunch of registers, but whatever. We'll include this, and then this is the default. And then, yeah, there's just a bunch of registers and configs. And then what I do, and this is just the most efficient way I've found to get stuff going, is I include this here. And then when you make a new library, you have to quit and restart the IDE. You can see I have like 8,000 IDEs because I'm like constantly testing different versions. I don't need this, and I don't need that. Go Arduino IDE. Okay, we're back.
Have some time before you need.
Yeah, I'm just writing code. Go do man stuff, whatever.
Yeah, I gotta. Yeah.
It's cool. So, oh right, I have to also. Ugh. Okay, then I just check to make sure I have like a basic compilation working. So the Arduino IDE has this like thing recently where if you have like more than a certain number of errors, like it doesn't show up in the error box. So hopefully that won't come up. Okay, so compiled, so like it found the file, so I didn't name anything wrong. There's nothing, and also it would have told me if I didn't have this semicolon. So now we can actually, for example, do the constructor. For this, which actually doesn't really do anything. Yeah, there's really no settings for this, so that's cool. And then I actually want to do my begin because that's actually where the action's at. And then I do pass in a address. So this is where for what I've totally learned, especially since today I had to like rewrite some liquid crystal library. Basically, don't do anything in the constructor, and other than the most like minimal things. Oh, you know what we have to do in the constructor though? I have to call the GFX constructor. I have to call the GFX constructor because that's where you set the width and height. So it's where I can't remember whether it's height then width or width and height. And hold on, I'm going to. Whoa, there's too much stuff open. Why is there so much stuff open? I'm going to check back at the Neo Matrix to see what I did for the constructor. Oh, it's width height, right. Close this. Width is 16, height is 9. So that's how many pixels wide and high. And that tells the GFX library, like, okay, well, if you ask it for the width, it will know it. It's kind of handy to know. Okay, so begin. And yes, I want to have it default to the default. Bam. Set the address. Default to 74, but whatever. And then I'm just going to pretty much gank all of this. Turns out I already have the code for setting the address. Set the start wire. Remember, you can't call wire begin in the instantiator. Don't do that. Call that in begin instead. And then we just have a couple of functions. And there's picture frame, whatever. Like again, it has like 8 frames you can use. And then you can turn LEDs on or off. 0 PWM. I'm actually going to do the opposite. This is turn all LEDs on in this frame 0, each LED, each 8 LEDs on. I turn each LED on and I set each LED to PWM 0. So that's that. And then I actually have to kind of copy and paste all of this super fun bank setting. It's actually interesting. So you have I2C, which has a kind of standard 8-bit registers, right? You have register 0, and that's usually your control register, and then you go all the way down to OXFF, although usually you don't even have 256 registers. But this one has a register for each LED for the PWM setting, 8 bits, so it's 1 byte. So it's 144 bytes per frame. There's 9 frames. So it's like we're talking about like it's getting close to like a K or 2 of RAM needed for all of the PWM settings and like LED settings, everything. So they actually use banked I2C registers. There's one bank that you set the bank and it's the function register, and then you have other registers that you set, other banks that you set for talking to the frames. And yeah, I mean, you check out the data sheet if you want. It's not that unusual. Of all the weird I2C implementations I've seen, this one's not so bad. This is not nearly as bad as Scilab's, which has just like super weird I2C. Okay, where was I? I was copying and pasting. So grab all this, paste it in.
Do you think anyone else is broadcasting live Arduino library writing right now?
Right now, there's actually 7 other people on Twitch that are writing Arduino libraries.
not.
Yeah, no, it's high competition.
That's not true.
Yeah. Yeah. Okay, so we'll add the select bank, and this is what determines which bank you want to use. So there's a special command register bank, and then you write the bank. Write register, which does exactly what it sounds like. It actually writes a register to a ANCB, to a bank. And then read register, which does the same thing. It just reads it. Oh, my battery died. Oh well. It's okay, I can do this in the dark. Now I know that the battery only lasts 30 minutes.
Hacker mode.
Yeah, hacking faster. Okay, so you got the read register. You have to wire up the power plug for that. You know, gotta get to that. That was not important for today. Okay, so you got read register, write register, select bank, begin. Oh, and then of course set LED PWM, which is kind of like where the action happens. So for that one, you have the bank, and then you just have this offset 24, and then you add the LED number, and then that's actually how you set the PWM. I mean, it's interesting is this chip is, I've never seen another chip that does per LED PWM. I've seen ones that are like, oh, we dim the entire thing, but I've never seen ones that individually dim them. That's why I'm like pretty excited. I don't know if you can tell I'm excited, but I'm excited. Okay. Don't need this anymore. Don't need this anymore. Don't need this anymore. Oh, I do want to set, sorry, LED PWM. I gotta put this here. And I'm going to have that, I'll have that be public. But I want the bank to default to 0. Okay, so now I can create the object. I'm gonna call this LED grid, LED matrix. And then just add the object file, and we'll see how this goes. Now we get to clean up our mess. Yeah. Undefined reference. VTable. Oh, because I didn't actually make draw pixel. Right. Gotta do that because VTable is the virtual function table. Gotta make this. So I'll do the math in a little bit, but okay, so you got your draw pixel, and I'll actually just I'll be horrible and just return. Yeah, fix me. Okay, compiled. So let's see if I am back where I was, but now objectified. I got this on gamma table. No, I am not. Did I miss anything? Oh, did I called begin. Mm. Okay, I want to make sure that everything got called. My squared address equals address, which is 74. Just for fun, though, I gotta make sure I call that. Now you get to see where I broke it. I did set the address to address, so that's good. Register, let me see. Let me see actually. I messed something else up with the, you know what actually I should do? I should not do the GFX sub class first. I'll do that later. No, still not seeing it for LED, CPWM. I'm gonna set this to how about I do this? Oh, you know what? I know exactly what it is. It's because I had it on audio mode, and now I'm not using audio mode. Ha. Okay, so remove this. And I gotta disable audio mode, which was nice. Oh, you know what? I guess it's by default on. Oh, because I didn't power cycle it. So the last time I did it, when I had audio sync on, that stayed on. All right, that's cool. I'll do a full power cycle. Yeah, I'll just unplug and then replug. Okay, what I should do is I should remind myself to, I do come out of shutdown, but I want to do a full register clearing. So maybe software shutdown, that's what I want to do. Set the software shutdown mode. So shutdown register. This is really cool. You can tell this is like really weirdly translated because it's page night. So this is like the most goth of register pages because it's like page 1 through 8 and then page night. And another interesting thing about page night, which is probably page 9, is it's actually page number 11, which maybe is why they called it page night. I don't know. Okay, so there's a shutdown register, OAH, so let's go check that out. By setting the shutdown bit, it will operate software shutdown mode. They're all off, and then doesn't sound like it actually clears them, but I guess we could do it because we have red shutdown here. So maybe shut down by writing that to 0. By setting the SSD pin to 0, it'll software shut down. But it doesn't really say whether software shutdown actually does anything. So whatever, we'll just do that. Shut down. And then give myself a little delay here. And then come back out. Okay, so we're back to where we started. Like you got this LED matrix and it's like in moving and stuff. And now let's add that capability of drawing a pixel. So fix me, why, of course. So we're not going to have color be like RGB color. Usually it's a 16-bit RGB color, but instead what we're going to do is we're going to have it just be the 8-bit PWM. So, you know, if color is larger than 255, just set color to 255. This is our PWM 8-bit max. And then what we're just going to do is the LEDs go down the X and then they wrap around for the Y. So we have to also check that the width and height is fine. So if X is larger than, so it starts with 0 and it goes to I'm not sure it's 16 pixels. Now I feel like I have to get a check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if it's larger than 16, because 0 through 15, turn. Actually, I also have to check if it's negative because it's an int. X is smaller than 0 or larger than or equal to 16 and return. Likewise, if y is larger than or equal to 9 or 0, also return. Okay, so now at least we doing the right thing. So don't forget your close parens. Yeah, thanks, Axemax. I know. All right, we're back. So if x it goes x, 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 and then it goes column by column by column. Sorry, row by row by row, and then increments. No, goes increments the column and then increments the row. So what we want to do is set the LED PWM to be x plus y times 16. Increment the x, and then every y increments by 16. We'll see. I think it's probably right. And then by color. That's it. So that's all you got to do. Just basically, you're taking the x and y, you convert it into however you set the pixel, and it writes the I squared C. Now, it will take a little time. You know, it is a full I squared C write per LED write. If this is slow, we can always speed it up with faster I squared C. Okay, so now let's just yank this, and then for x, starting with x until 16. For y, y is smaller than the height. Increment. And then we will draw a pixel and just fill that pixel in with 127. So not the brightest, but you know, not dim, and then return. And then let's put a little bit of delay so we can sort of see this happening. And oh, this is annoyed with me. Actually, I'm just going to comment this out. I don't want to deal with this. I have like 18 test things going on here. Reset the COM port. Does not see it. I wonder if this current draw made it unhappy. Oh, I totally just broke my Metro. Maybe I can plug it into this USB port. Well, actually, why would it not? This USB hub is not working. No. Check the device manager. No, it totally doesn't see it. Okay, I gotta find another way to plug in. One moment. Let's see if that did it. No? Oh my god. I totally did break this Metro. Okay. Well, that's not going to stop me. I have another Metro. Oh, you know what? I have this thing where the Windows just completely dies and hates everything, and I have to reboot. That's sad. Yeah, my USB driver just died on Windows. That's doing LEDs. Well, I could reboot it. Do you want to reboot?
Yeah, reboot. I don't know what's gonna happen with the casting, but go for it.
Whatever. Later.
We can do a live reboot.
Kill it.
Anything is on your screen.
Yeah, I know. Bye. Gotta go. I hope it doesn't decide like to install like the 18 updates it was saying it's going to install. That'd actually be a really good Twitch, just like installing updates for Windows, installing Windows 10. It's probably going to install Windows 10 on me now. Yeah, this is so unhappy. All right. Time to euthanize this. Doot, doot, doot. Computers are awesome.
Yeah, we've never rebooted with.
I don't know what happens. Maybe they'll see my BIOS screen. I don't know.
Yeah, I don't think so. I think you need to have Windows on first.
I hope my computer boots. Hey, you gonna make it? Is it booting? Wow. Yeah, there's a blue light. It's just very dim. That'd be cool if it just died. Yeah, I wonder. Oh, you know what? It might. Yeah, it might not like the.
Yeah, it's on the top box, silver box.
Yeah.
Just unplug it.
Okay.
No, zero.
Oh.
Yeah. Try it
Well, I have a spare computer at the office. Tomorrow I could install it. See, it's not easy to write Arduino libraries. You have to like
Yeah.
update your BIOS. Okay, so now it's booting. Yeah, it doesn't like booting if you have the external HDMI.
Oh, yeah.
It's booting. You guys can't see it, but it is. Got the BIOS screen. Okay, where was I? You know what's sad? Like I have to. That happens to me so often that I'm just used to it now. I'm like, oh yeah, the USB just like totally gorked the entire install. I got to start over.
Yeah, plug it in, see what happens. Make sure
HDMI in.
yeah.
All right. Okay. Well, we have our USB COM port
Back in business.
back in business. And that's what engineering is really about. Okay, so we have our USB port. Let's go back to where we were. You can't let it bug you. You just gotta keep going. And I'm gonna reopen my. This is also, by the way, why I have Dropbox installed. I'm not a serious promoter of just Dropbox. You can use any cloud storage system, but like, boy, not having to worry about like your hard drive not flushing the file cache is totally worth it. Okay, so I was working on the ISLI. Okay, got that. This was in my sketchbook under LED. Okay, now compiling. Actually, I wanted to use my Metro Mini. Which is port 12. Okay. No whammies. Okay. Okay, so it looks like it worked, but it worked a little bit too fast. So what I'm going to do is do this and then turn each pixel off. So it'll turn them all on, turn them all off. We'll see if this works. Okay, great. So, can you show the overhead
Yeah.
before something else explodes?
It's time to get back to business.
We're pretty much done. This is like the near end. So, so now you can see I've got every pixel turning on, and it's doing it correctly. It's doing all the Y's first, Y, and then by X. So that's great. So now what I can do is, and I'll just write the code for it. You notice all I wrote was draw pixel. I just did the XY draw pixel code. Now I can add like text scrolling. So let me, 1 second, I'm gonna grab my example for, sorry, examples. And it was the dot star matrix, just so I have the text. I want to have text wrap off. So no text wrap. Set text color to be again 127. And then matrix. Set the text color to be 127. LED matrix. Set text size to be 1. And then in my loop, I can just call LED matrix fill screen 0, and then set the cursor. No, because I'm just going to be, as soon as I compile this, I'll go to this afterwards. Because I'll compile this, send it over, demo it, and then we can go back and look at the code. That makes more sense. And add a delay. Oh. I actually have to clear the screen. I don't have a clear screen function. I will write that later, but for now I'll just draw 0 to every pixel. Okay, so uploading the code, and I can just have text scrolling. And all this text stuff is handled by the Adafruit GFX library. So all I have to do is tell it how to draw a pixel, and then I'm like, okay, you've got the font code ready to go. I can also, like, you know, let me see, I'm going to set the cursor to be 1. So now it'll move down 1 pixel. You know, so I can move the text around, and then if I want, I can do I can fill the screen 16 by 9 with a very faint color. And then I can have like this color in the background. I'll actually remove the clear screen because it looks a little weird. So I'm clearing the screen, and then I'm writing it with a faint color. All right, so now it's a little smoother. So there's a faint overlay, and then if I want, what I can do is I can make it bright and then set the color of the text to be 0, and it'll basically invert it. Waiting for it to upload. So, okay, it's a little bright. Maybe I'll make that a little less bright. But like, it's much, much easier now to do graphical stuff when you have like this underlying library. So I guess the lesson of the day is code abstraction works if the abstraction makes sense. And if it doesn't make sense, then you can basically, you know, go to town with something like a graphics library, which you can write 3 or 4 years ago and then adapt it to multiple new products. So the GFX library was definitely a win. It's been annoying to maintain, but you know, if I add a new function or a new font, then basically it can be implemented, and like all you have to do is just pull the latest version of the GFX library, and then for like this code, they automatically get all of the extras. So that's that. Howdy. Maybe I'll change that to something else. And recompile. Okay, and that's pretty much it. I'm going to have it say goodbye, and then we're going to say goodbye.
Yeah, well, let's go into overdrive.
Well, it has to say goodbye first. Good. But I. Exclamation point.
Okay. So we're going to go into overdrive.
Okay.
Overdrive is breaking AV stuff.
Okay, let's break
I'm
stuff.
going to unplug your computer.
Yeah, go for it.
Okay. And can you hand me the HDMI cable that's plugged into that monitor?
Yeah. Now's a good time for someone to just hammer. It's like, it's the bats. It's the bats that I annoyed last time. Remember somebody said, why are you making the bats angry?
we unplugged your screen, and
Yeah, you don't need my screen because my screen's just boring.
yeah. So I'm gonna. It's gonna have to do this live. So
Do it live.
yeah.
I'm gonna change this brightness.
So I believe that it's 1080i.
I think it's 59.94.
Yeah.
I'm guessing, yeah. No, maybe it's.
Wow. I did it.
1060. Okay, great.
Okay, so maybe you can tell folks what this is.
Okay, so I picked up a toy. It is
Well,
in.
you can show this on the overhead.
Ooh, weird.
Yeah.
So this is kind of. I don't want to yank
No,
it too hard.
that's fine.
Yeah, this is an HDMI. Here, I can actually move this. This is an HDMI output camera that's a microscope. So on the top, it actually has a USB plug, but then it has this is a mini HDMI plug as well. And basically, it is just a really nice. It's a 200 multiplication. Microscope, but it has HDMI output, so you can get like really good quality. So, for example, if you wanted to,
Let me focus on it.
yeah, I want to focus in on this. So this is like that LED grid, but this is one that's not completed soldering. That's focused. So you can see like all the little pads and stuff. More fun, we can have a Metro. A second, hold on. You have to hand. Do it, but like you can get really in there. And then what's neat is I have a cooler thing. 1 second, let me get my cooler thing. Where's my cooler thing? Cooler thing is in my bin. One second, I'll be there in a moment. Come on, where's my cool thing? I don't have anything cool. One moment. I'll just show like a NeoPixel or something. I have like no NeoPixel stuff. Just like the one time. Okay. Well, what I can show is not only can you get into an LED, but if you keep focusing, it has 2 focal points. So you can focus at a high.
So you're even closer.
Yeah, there's the higher resolution focus, but I'll have to hold it very still.
Whoa.
Yeah, but I'm holding it by hand, which is why it's really hard for me to get it perfectly in focus. There you go. So you can actually see like the die of this LED.
Is
Kind
it
of neat.
possible for you to let go of it?
No, because it's
It just moves so much.
we have to. Oh, you know what? This actually. Never mind. This adjusts. Ha. Okay, so there you go. So you can see like really big solder points and then an LED. Yeah, that's kind of cool. I thought I had like some dot stars or LEDs in here somewhere. I don't know where they would be. Yeah, I don't have anything else that's really small. What else do you think I should show off?
Yeah, that's good. It's cool that this test works.
Yeah. But I thought I had some NeoPixels. Those are always fun to look at because you get the multiple dyes inside the LED? I don't know. It's kind of weird. Oh, here they are. I knew I had some somewhere. These are mini NeoPixels. So, yeah, so that's kind of neat.
You can focus on it probably better.
There you go. So you can actually see bonding wires now. So you can see there's the NeoPixel chip, and it has 1, 2, 3, 4, 5,
Wow,
6.
I can see the silicon there.
So yeah, barely.
Is that a QR code on that?
No, no, no. It's another bonding wire. So it looks like there was. No, I think it's just it's a point where you can connect to, but it's not connected to.
Yeah.
But you can see here, we can tilt it. Hey, that's kind of cool. Look, you can sort of see the circuitry a
Oh
little
yeah,
better.
look at that. That's pretty cool.
Yeah. And then you can see it's bonded to here, hold on, I'll get my I can't really fit that in here. Okay, yeah, so there's the red and then yellow, green, yeah. Well, I was thinking if I could reach in, but when I reach in, it pushes it around.
Very good though, yeah. Wow.
Yeah, it's cool. These are the mini NeoPixels, so if we had over 200 times magnification, we could zoom in and actually see if there's any writing on it or any other interesting things. But you can see the LED drivers, those big pads.
There's a lot of transistors right there.
Yeah, there's going to be a bunch of logic. I mean, there's not a lot going on in these. I don't know. I mean, it definitely looks like another pad, and you know, I know that there are RGBW LEDs, but you know what? That's probably let's see, which could be an alternative power pad. Like there could be a LED power and chip power. Because there's definitely power and ground, and then the three. There's power, ground, input, output, and then 3 LEDs. So there's 7 pads, and then like why would you have an 8th one? I don't know. There's a little bit of mystery, and also like the places these come from. It's like you don't even know exactly who manufactured this chip, and then you can see that there's 3 dies, and then the red one is bonded right down to the metal on the LED sort of substrate, and then you've got like the green and blue, which are those little white squares, and those are just kind of like placed wherever, and then the little wires go, basically through the diode on the little chip, and then it's bonded onto the positive voltage, which is the because they're all common anode. Okay, well that's kind of fun.
Alright, we did it.
So we can show off stuff. I mean, like we can show off soldering in the non.
When this works, and I can switch between video sources live.
And then this is kind of the magnification you want to deal with, but we want to be.
It's focus now.
Yeah, well, every time you move it, you have to keep it refocused. So that's the thing. It's a little tougher,
Yeah,
but then we can actually point at stuff like.
Yeah, but you're out of focus right now, so can you focus a
I
little bit?
am focused.
Yeah.
Is it? That's
Yeah.
out. That's out.
You
That's
just
it.
pass it.
Well,
There you
it
go.
depends
That's
on
it.
whether you want to have the
That's
chip being
That's
focused.
focused there now. See how focused that is?
Yeah. Well, but I was focusing on. I guess yeah.
That's blurry now.
Okay.
That's focused.
I see.
A
A little bit more,
Yeah. Nope. Other way.
dude.
Other way.
I'm doing it slowly.
Other way, other way.
I'm doing it very
Keep going,
slowly.
keep going,
Slow,
keep going,
slow,
keep
slow,
going.
slow.
Nope. Back a little bit.
That's as good as it's
That's
gonna get.
Yeah.
Okay.
Like a science fiction thing. Those are like little robots robot babies.
And then we could do like surface mount soldering. We could basically just do like, here's how you solder a QFN. People are like, how do you solder a QFN? I'm like, yeah, that's not so bad. Actually, what's interesting, this chip is that we were just playing with is a 0.4 millimeter QFN. So that's 0.4 millimeter. Sucks. 0.4 millimeter totally sucks. But you can do it. And this is hand soldered, and you just very carefully do you put a little bit of paste, and you pin it down, and then you drag solder, so it's possible. But then this little chip, and then you see all the LEDs go out, and the trace is actually quite thin coming off of it. It's only 8 mil, or even a little bit less, 7 mil, but because it's multiplexing these LEDs, and you think like, oh my God, it's like 144 times LEDs times 20 milliamps, and like, you're dealing with like amps of current, but because it's not driving LEDs at the full current, it's driving them at like 3 milliamps on average. It's only 300 milliamps total. It's not so bad.
Is there any settings on the camera that lets us take away the menu items, or is it just like, no?
I have no.
So it says there's a memory card that I guess we could have in it, and then there's a brightness, but does it say anything about menu? Does it say menu on it? Say menu?
Yeah, it says menu.
Alright, go to the menu. Oh man. Alright,
It'll
go
never.
to quality. See if we can increase the quality.
Economy.
No, I guess fine is what we want. No, go to.
I know.
Yeah. Okay, go to resolution.
All right, hold on. Oh, date stamp. We want to take that off, right?
Yeah, I'm off. Okay.
And then exposure, we also want to remove, right?
No, that's fine. Resolution, yeah. Oh, go to 14.
Wait, fuck, if I start. Oh, God damn
I
it.
know.
These buttons are very small and they're very confusing.
Okay, go back. But go to resolution and
All
go
right, hold on.
to. See if it actually. I think that's just for when you're writing to a card, but we'll say.
Yeah, menu. No. Resolution, and then, okay. And then, okay, so you want to select this? Okay.
Yeah, no card.
No, it's just for
I
the
don't-
card.
yeah, okay. Let's see if there's any other things.
Okay, menu.
Yeah, go to resolution again. And is there anything?
Yeah, it doesn't like it at all.
Okay, and then there's another thing when you're in the menu. There's camera, and then there's settings. Can you go to that one?
Yeah.
Okay. Good. Scroll down, keep going. Let's see if there's anything else for this one. Keep going, keep going. Okay, go to TV mode.
Okay.
Okay, that's what that is. Alright. Okay. So
We didn't really get it to take off the. I
yeah,
mean, we could muck around and maybe.
yeah, it probably is permanently on there.
It's probably permanent.
Yeah.
It's not so bad. I mean, it's not great, but.
Yeah.
And then you can take, there's a micro SD slot in here. I'm assuming. This is a very fancy camera. Yeah, there's a micro SD slot, and then we can take photos, which is kind of cool. We can take like very fine photos. All right, well, I'm done. That's exciting. I wrote a library, said howdy, and
Okay.
totally crashed my computer.
Alright, and with that,
Yeah,
we are going to call it a night.
I totally agree.
Yeah. And, get me out of here. Bye-bye.
Goodbye.
Okay.
Hacker mode.